Right, this is the asynchronous lesson for 9B, week 5, period 4, or lesson 4 of the week. And it's an explanation of the homework for this week, which is in the homework booklet, pages 6 to 9B. So if you go up to page 9, just rename that 9A, and the next page is 9B. Okay? After that will be 10, but that's a different topic. So, start with page 6. The student separated sugar from pieces of broken glass by dissolving the sugar in water and filtering off the broken glass. So there's the filtrate label there and the filtration apparatus. By the way, this reminds me, even though they've done it themselves here, examiners in the past have warned against drawing apparatus floating by itself in midair without being held in place with another suitable piece of apparatus. So examiners in the past have actually criticised this, and then they've gone and done it themselves. And this is quite annoying and irritating. They do this sometimes. They'll criticise students for something, and then they'll go and do that same very mistake themselves in other exam papers. So the point is, this should be held in place by a clamp and stand. Yeah, retort stand and clamp, like that. It shouldn't just be floating like that when you draw it. Like I said, they've made the mistake themselves, but you should be careful that you don't do the same thing. Another alternative is to draw it resting on top of a conical flask, so that the filter funnel goes directly in here, and then you've got the filter paper, and so on and so forth. Okay, and that way the top part of the conical flask actually supports the filter funnel, and you don't need a retort stand and clamp. So these are the two options you've got. Right, anyway, what is the filtrate? So if you start off with sugar, solid sugar, and broken glass, then by adding water, the sugar dissolves, but the glass doesn't. So now you're going to have sugar-water solution and solid glass. So how do you separate the solid glass? By filtration. So when you pour that mixture inside, you're going to get broken glass as the residue, and the filtrate is going to be the sugar solution. Filtrate is going to be the sugar solution. Next, the diagram shows the first step in separating sand from salt. What is the next step? So if you started with a mixture of solid sand and solid salt, okay, then obviously because of the diagram, you can see that they've added water. Okay, and now you've got the sand and salt and water mixture. Now what's going to happen when you add the water? The salt is going to dissolve, but the sand is not, because sand is insoluble in water. So the salt's going to dissolve, and you're going to end up with a salt water solution and insoluble sand at the bottom. So this is going to be your salt water solution. I don't know why the writing seems to be very laggy at the moment. So you've got your saltwater solution and your insoluble sand here. So what would be the next step? The next step obviously would be to filter, okay? To remove the sand, all right? That would be to filter, which is B. Now, some students, a lot of students actually, they put the answer A. They put the answer A, evaporate the water. But then my simple question to them would be that if you started with this, sand and salt, and then the next thing you did was to add the water, why would the next step be to evaporate the water? Why evaporate the water that you've just added? Or, in other words, why add the water if you're then just going to evaporate the water? Doesn't make sense. So think about what's going on and try to understand it. Next, which method is used to obtain a sample of pure water from a salt solution? So we did that, simple distillation, which is C. Okay, to obtain the pure solvent from a solution. Next, question 4. The diagram shows a method for separating a mixture. So you've obviously got filtration going on directly into an evaporating dish. This method could be used to separate what? So in other words, filtration is used to separate an insoluble solid from a liquid or a solution. So out of these options, which ones are insoluble solids? So A, you've got chalk from a mixture of chalk and water. Is chalk insoluble? Yes, it is. Remember, chalk is limestone, otherwise known as calcium carbonate. Different form of calcium carbonate, comes in 3 forms: chalk, limestone and marble. So that's insoluble, so that's the answer, A. But let's just go through the others just to make sure. Ethanol from a mixture of ethanol and water. Ethanol dissolves in water. We came across this when we did simple distillation or fractional distillation. Okay, separating. We also mentioned it when we talked about separating immiscible liquids. Okay, immiscible means they don't dissolve in each other, but rather form separate layers. And we gave the example of the opposite of that, which is miscible, like alcohol, like ethanol, which is an alcohol, and water. So this one wouldn't work. And then pure water from seawater. If we want the pure water, we want the water, the solvent, from the solution, seawater, then we have to use simple distillation. Okay, then we use simple distillation. And then sodium chloride from seawater, again, because the sodium chloride is dissolved in the water to make a solution, you can't use filtration. So A, again, is the answer. Number 6, sodium chloride dissolves in water. Which method is used to recover all the sodium chloride from the solution? This time we want the solid sodium chloride, okay? We want the solid sodium chloride. In other words, we want the solute which is dissolved in the solution or in the solvent. So the way to get that is evaporation. In some questions like this, they intend sodium chloride crystals, in which case the best answer would be crystallization. But that's not an option here. They didn't mention crystals, so that's why simple evaporation is the best answer. 7. Diagram shows a chromatogram used to find out which colorings are in the fruit drink. So which 2 colorings are in the fruit drink? So here's the fruit drink, which is split into these two components. So to identify from these chromatograms or these colorings which two substances these are, you can either use a ruler or you can do it freehand, but you can see that this one matches at this height, which means it's the same solubility and has the same RF value as this, number 2. And this one matches with this, which has the same solubility and RF value as number 5. So it contains 2 and 5, which corresponds to D. Next, tartrazine. Now this one is a very big question. There's a lot of information. There's a big, page full of diagrams. And then you've got 3 questions here and another 4 or 5, actually more than that, 6, 7, 8 questions there. And there's a lot of marks. Just this section of 4 steps is worth 8 marks. So it's a big question. So the first thing you need to do is read through all the information carefully. Tartrazine is a bright yellow dye used to colour food. In Europe it's given the label E102. The use of tartrazine has been stopped in Norway and Finland since 1981. It's still widely used in the UK, much of Europe and in the USA. The series of diagrams below shows how a coloured sweet may be investigated to see if it contains tartrazine. So you've got some chocolates like Smarties, one of my favourite chocolates. Okay, so you got some chocolates, coloured ones with a coloured kind of coating. You know the ones here, like Smarties. And that's step A. Alright, you can see what's happening to them from the diagram. Okay, and by the way, this piece of apparatus, which I should have mentioned to you during the week in class, is shown in the cover. Okay, the cover of the book, this homework book. So this, which you should have also been asked to label, if I forgot that, then do it now. This is called a mortar, M-O-R-T-A-R, and this is called a pestle with a silent T, pestle. So together they are the pestle and mortar. And they're used for what? They're used for crushing substances to increase their surface area for faster either dissolving or reaction. Faster reaction or faster dissolving. You have to make sure you get it right. Make sure you understand what's going on. Is it a physical dissolving process? For example, sugar in tea or salt in water? Or is it a chemical reaction where the solid that you've crushed is actually going to chemically react with whatever else you're adding it to? Okay, because they're different. Physical and chemical processes are different. That's what it is. Pestle and mortar. Chocks are being added to there. We'll get back, obviously, for the purpose of crushing them. You can see that, for the purpose of crushing. Try to understand what's going on in the diagram before you even get to the questions. And that way, when you do get to the questions, you'll realise you already know a lot of the answers because you've analysed the diagrams and thought about what's going on. So, the powdered chocks now are being added to a beaker along with some water. And then that water is being stirred with a glass rod, heated with a Bunsen burner, and the powdered chocks are in there. And that's step B. And then step C, obviously filtration. There's some insoluble chocks there left over after that. And then they're being filtered straight into an evaporating dish. And then some evaporation is being carried out, but not complete, okay? And it's not to form crystals, but rather transfer some of that concentrated solution onto a piece of chromatography paper, and then the experiment of chromatography is carried out. So let's go through the questions now. Answer the following questions about this investigation. Name the steps B, C, and D. So step B, remember we added the chocks to water. We're stirring and heating for the purpose of dissolving. The chocks are not going to react with the water, okay? So they're going to be dissolving. As you can see, initially we added quite a lot of chocks, but at the end there's only a small amount left, so most of them dissolved. So step B is dissolving. What about step C? That's obviously filtration or filtering. Or filtering, you can write. And step D, this is step D. So what do you think is going on in step D? You can see that we're evaporating some of the water from that solution, okay? So there's evaporating. But what's the purpose of it? The purpose of it, remember, is to concentrate the solution, to darken the colour, as I would have explained to you during the week's lessons when we did chromatography. One of the first steps is to concentrate the solution, if you're dealing with a coloured solution, to concentrate it by evaporation to darken the colour. So you could put evaporation and that would get you the mark, but personally I would add that extra little bit of detail, which is concentration, okay, because the purpose is to concentrate it by evaporation. So I would say concentration by evaporation. Okay, next page. The big page with heavy marks. Explain the purpose of each of the steps A, B, C, and D. So, the purpose of A. Now, these are open-ended questions. Each question is 2 marks, as you can see. Total of 8 marks here. And there's 4 questions. Okay, so 2 marks for each. And as you can see, they're open-ended questions with plenty of space for you to elaborate further if you want to. They're not specific restricted questions like name such and such, or give the temperature at which such and such. Do you understand? They're not restricted specific questions like that. Rather, they're explanation questions which are more flexible and more open-ended, so you can add extra information. And this is where the opportunity comes for you to impress the examiner by adding some extra details, as long as you're absolutely sure that they're correct. For example, names of apparatus. Okay, even though they're not asking, if you know the names of the apparatus that is involved, then throwing that in there looks very good and improves the quality of your answer. So the purpose of step A is obviously to crush the chocks, but you can add into that, the piece of apparatus you're using, i.e. pestle and mortar. So something along these lines. So crushing the chocks using a pestle and mortar to increase their surface area for faster dissolving. Yep, that's fine. That'll do. Okay, for the next one, let's have a look. For B, remember in B, we added the chocks to the water, so now we're trying to actually dissolve the chalks in the water, okay? But in order to speed that process even further, in addition to having crushed them, to speed up that process even further, we're going to heat with the Bunsen burner and stir with a glass rod. So we could say, let's see, dissolving the chalks in water and speeding up the process by heating with the Bunsen burner and stirring. Then step C. So in step C we can see we're filtering to remove any undissolved chalks from the rest of the solution. And then step D, we are evaporating some of the water from the solution in order to concentrate it to darken the colour. Because remember, when you transfer it onto that chromatography paper, if the colour is not dark, you're not going to be able to see it. So, like I said, for step D, you would say something like concentration by evaporation to darken the colour. Or you could say evaporating some of the water from the solution to concentrate it and darken the colour. Right, okay. So they're the answers for that section. Use those to edit your answers and make sure they're perfect. If you're not sure about your particular wording, remember you can take a picture and send it to me on WhatsApp or send it on the group. Next part, what's the name given to step E? Where's E? So step E is here. And this is chromatography. So step E is chromatography. Don't mix it up with the chromatography paper or the chromatogram. The chromatogram is this, the final result of the chromatography experiment on the chroma. The result of step E shown below. Did the yellow coated chocolates contain tartrazine? Explain your answer. So, here's tartrazine. Here's the sample from the chalks. Obviously, this was the original place where they were put on the baseline, or the datum line, or the origin line. And the sample of chalks contained two substances, shown by these two positions. And the pure tartrazine, obviously, is only going to be one position. So, does the tartrazine match up with either of the two components in the chalks? No, it doesn't. Okay, so how would you put that into words? That's the question. So, there's different ways, but the two best quality answers are going to be those that use either solubility in your answer, okay, matching solubilities, or non-matching solubilities, or RF values, rather than the matching horizontal position or the matching vertical heights travelled by the spots. Okay, that is all true, but the quality of that answer is not the same or not as good as talking about, you know, this one having a different RF value to this one, or these two having different solubilities, because remember, the whole point of how far up the paper they get carried is based on their solubility. So here's an example of an answer. Okay, what is meant by pure tartrazine? So remember, what is meant by pure anything? Go back to the notes, check the definition of pure. and you'll find that it is one substance only, unmixed with anything else. But here it's not asking what is meant by pure. Okay, it's asking what is meant by pure tartrazine. So instead of just making it general for any substance, you have to make it specific for tartrazine. So for tartrazine, you would say, okay, suggest a reason why the use of tartrazine in foods has been stopped. Remember, right at the beginning of the question, there was some information about it being banned in certain countries. Okay, why would someone ban the use of something in food? Now, normally I get a lot of answers. I normally ask this in class, and I get a lot of answers ranging from things like it causes cancer, it causes hyperactivity, it causes diabetes, it can cause allergies, it can cause all kinds of things. Students often mention a lot of different specific health problems, okay? And unless you have actually studied tartrazine and what the specific health problems are, you can't write stuff like that because you don't know. Because it's not in the syllabus. I'm not going to teach you about tartrazine and what its specific harms are, okay? Because you don't need to know. So very often in your exam, you're going to get questions about things which are not in your syllabus. Does that mean it's unfair? No, because they want to see who has got the common sense and the ability to apply knowledge using their common sense. So the fact that it's been banned from use in foods, they don't want a specific answer like it causes this or it causes that. They just want general common sense. And that's what you find with most questions that start off with suggest. Most questions that start with suggest are those where you haven't studied the answer because it's not in the syllabus. So they want you to use your knowledge of something similar to it or something provided in the question to answer the question. Okay? So in this case, they're looking for a very general, very simple answer. Why might something be banned in the use of food? Because obviously it is harmful in some way. How is it harmful? They don't care. They don't want to know. They're not asking that. They're asking for you to make a very general, simple, basic statement of why it might be stopped in certain countries. So it may be harmful. Okay? It may be harmful. Okay, the last question is this, which I'm not going to write out the answer all over again because we would have gone through this in class already. I would have talked you through a very similar, almost identical example, okay, using the scribble in red ink on my notes example. And then we would have compared it to this question, and you would have realized that it's almost identical. The only difference is that the ink here is from a forged banknote, okay? And your job is to find who the culprit or the criminal is who forged the banknote, as opposed to the example I used in class, okay? So, if you understood that example, all well and good, you should be able to apply it to this question. If not, go back to the recording of that lesson, listen to it again carefully, and use it to help you construct the answer to this question. I'm going to talk through the answer to this as well, but I'm just not going to write it down because it's going to take too long and I need to wrap up the lesson now. Okay, so the question says forged banknote. A fake banknote can be investigated by dissolving the ink off the paper. You are provided with 4 different inks from 4 different criminals. Describe an experiment to show which one of these inks is the same as the ink from the banknote. You can use a label diagram to help you answer the question. First thing is, when it says you can use a label diagram, it means you should use a label diagram, okay? It's giving you a very strong hint that using a label diagram is going to help you immensely in getting the marks for the question. In fact, most of the marks from the question can be got directly from the label diagram. Most of these 6 marks. Now don't look at these 6 marks and panic and think, oh, 6 marks, I need to write and draw so much. No, there's basic simple things. Like for example, the word chromatography paper, okay, is going to get you 1 mark. The word solvent or suitable solvent is going to get you 1 mark, okay, and so on and so forth. So, you know, a lot of the marks are just for single words and simple things. So basically, the best thing to do with a question like this is actually start off with a diagram, because then you don't need to talk about how you set up the apparatus because it's already shown in the diagram. And the first thing that you would say was set up the apparatus as shown in the diagram. So you could draw a before and after version where you've got the beaker and you've got your chromatography paper, okay, and you've got your solution, you got your baseline drawn on there, all right? So that could be your before diagram, and then your after diagram could simply be the final chromatogram, right? So there's the baseline after you've taken it out of the paper. There's your forged banknote ink, which you've transferred onto there with a capillary tube. Forged banknote, and then 1, 2, 3, 4 suspected criminal inks. We can call them 1, 2, 3, 4, okay? And obviously they would have formed their own patterns. So maybe the forged banknote ink might have separated into these 2. Maybe number 1 would have separated into these 2. Maybe number 2 would have separated into these 3. Maybe number 3 would have separated into these 3. And maybe number 4 would have separated into this and this. Okay, these 2. So from this diagram, you tell me right now which suspect is likely to be the guilty one and why. And the answer is number 4. Why? Because the inks from the banknote match, both of them match in the same horizontal position as the inks from number 4. But remember, don't say horizontal position. If you want a high quality answer, you would say because the components or the samples in the forged banknote ink have the same RF values as those from suspect number 4's ink, or they have the same solubility. That's why they've travelled up to the same position on the paper. Do you understand? Now in class, I would have made number 3 the guilty person, but you know, you can make it number 1, you can make it number 2, number 3, or number 4. I've decided here to make it number 4, just off the top of my head, just randomly. Okay, as long as one of them you make it matching the forged banknote sample, so that you can identify it and talk about it in your conclusions for this experiment. Okay, and that's basically it. Once you've done that, you've got your 6 marks. But don't forget, you have to label your diagram. So in your before diagram, you know, you would have labeled, remember in your before diagram, you would have labeled the beaker, you would have labeled the suitable solvent, okay? Now, is it mentioned what the solvent is? No. So even though we know it's probably water, it's best if you just call it suitable solvent. And then you've got the chromatography paper dipped into there. The baseline, remember, comes above. So you'd have labelled all these things like chromatography paper, beaker, baseline, suitable solvent, right? That's 4 marks right there. That's 4 marks out of 6 right there. So don't be scared of questions like this. They're really actually very simple. Okay? And even if you don't manage to get all 6 out of 6, there's no reason why you shouldn't be able to get at least 4. Okay? And then the other things are just for making your conclusions, showing the comparison, showing the after diagram with the actual chromatogram, an actual example of a chromatogram. Oh, it's so laggy. What's going on? Yeah, so an actual example of a chromatogram, that would be your 5th mark, and your final mark is for making your conclusion and explaining how you would use that chromatogram to find the guilty person. Okay? So that's basically it. That's basically it. Most of it is the diagram, and then a couple of sentences, to make the conclusions. Now, obviously, high-level student might want to add a bit more, than just the diagram and so on. So he might, for example, mention at the beginning that the ink, which was dissolved off the paper, should be concentrated by evaporation to darken the colour. And then he would have also mentioned to transfer a sample of that ink onto the paper, onto the baseline, using a capillary tube, just like it says in the notes. Okay? So these additional things can also be mentioned to improve the quality of your answer overall and to impress the examiner with your detailed and precise knowledge of this topic. Okay? And so that's basically it.